Hey, Stefan here from Be a Python Dev. We're going to be doing some Leetcode today, particularly this move zeros problem. For this, we're going to be given an input array with some zeros mixed into it, and then we're going to move all the zeros to the end. The little caveat that we need to be aware of is that we're going to do this in place. So we're not going to make a new array. We're not going to copy anything over. We're not going to store temp variables. We're going to leverage Python's ability to kind of swap array indices in one operation to also do this. And we'll also be doing this in ON time. So one pass through of the array, which is definitely ideal, make this very fast. And if we needed to do this millions of times, it'd be done pretty quick. So that's always awesome. So let's look at the problem here and more particularly kind of actually talk about the example. So the example is 0, 1, 0, 3, 12. And then the output will be 1, 3, 12, 0, 0. So with the zeros moved to the end. Our thinking for this one is that we're going to iterate through the little array here. Every time we see a non-zero entry, we're going to move that to our zero index. So for the first pass through of this array, we see this 0, we're not going to do anything because it's 0. When we see the 1, we're going to move the 1 over to where our 0 counter is. We're going to increment that 0 counter up 1. So then we'd have 1, 0, 0, 3, 12. Next pass through, we see this 0. Again, we don't do anything. We see this 3, we're going to move it to the 1 increment because that's where our counter is. And then we'd have 1, 3, 0, 0. And then we see the 12, same thing, swap that with the first 0. Then we have 1, 3, 12, 0, 0. It's actually a little easier to code down than it kind of sounds like. We'll just keep our 0 counter here, iterate through the little fun lists that we're given. So we can't use I because I is going to be our 0 counter. So 4j in length, in range, length nums. If nums j is not 0, do the little swappy bits. I almost wish this wasn't pink. I am using the Dark Reader plugin to kind of make this not be as bright. Hopefully this looks good on camera for y'all. I'll look at it just to double check. I may edit that out, who knows. But back to our problem, if nums j is not equal to 0, we're gonna move that value to, actually we're gonna swap them. So nums I, nums j, this cool little swapper operator that Python lets you do. Nums j and nums I. And we increment the I counter. And again, if it's 0, we don't really do anything. So if our list, hypothetically, were 0, 0, 0, 0, we just look through it and we let everything stay exactly where it is. Or if it was 0, 0, 0, 1, we look through the end, we see the 1, we swap the first one with the last one, and that's also all we need to do. So let's run this. You can see our submission results accepted, run code status finished, input 0, 1, 0, 3, 12, our answer 1, 3, 12, 0, 0. Everything's good. Let's think through potential edge cases. There's the case we just talked about where if everything is 0, that's fine. If our nums list is empty, we're not doing anything, we're not returning anything, we're swapping it in place, so we're okay there. What about other potential edge cases? Is there ability for us to go out of our array here? Not really. I think we're good. We'll just go ahead and submit this then. Submission result accepted. Let's look more details. Here, this can tell us our runtime. It says our runtime is not very good, unfortunately. What are some of the quicker answers here? For I and nums, if I is num 0, this is literally doing the same thing that we just talked about doing, except he's doing an assignment, which you don't really need to do, I don't think. Oh, he's not doing the swapping. He's just assigning at the end. I don't think that this is particularly faster. It might just be a case where Leetcode decided to give us a high number, even though our code is not too bad. Memory distribution is also in the middle here. I don't know how you could do this to be more memory efficient than the swapping. Maybe Python is doing something in place with that swap that is causing more memory to be used than should be. Do not return anything, modify nums in place instead, remove lists for ion range. Remove list at append. I thought about doing this as well, where you're just popping the zeros at the end and then you delete the other ones, which seems what this is doing. It doesn't seem that much more memory efficient. Maybe because it's not using a temp variable behind the scenes in the one-line Python operator. Anyways, 4 lines of code to solve the move zeros. I think that's not too bad. Definitely could have improved a little bit on runtime to be more consistent there, and as well as memory. I think the problem with runtime is that Leetcode just decided to give us a high number. Let's run it one more time and just see if that's true. 104 milliseconds was what we had last time, and if we run it again, what do we get this time? If we run it again, we got 72 milliseconds. So I think this is just kind of a variance within Leetcode, because we're not really doing anything tremendously complicated here. So thank you. I hope you enjoyed the solution for move zeros. If you like these kind of videos, hit the thumbs up button and consider subscribing and follow Be a Python Dev. Thank you. Take care. Bye.